Hi everyone, I'm very excited to be part of ng-conf 2021. My name is Saranya Thangaraj and I work as Master Software Engineer at Capital One. I'm the mom of a 2-year-old and during my free time, I love drawing and painting. So these are some of my favorite pencil sketches. So let's jump into today's topic, SPA as platform with micro-frontends and capabilities. So what do we mean by SPA as a platform? So traditionally, front-end applications used to be single-page monoliths, and when the application became bigger, multiple teams contribute to it. So when changes have to be made, there needs to be a lot of coordination and testing between teams. This causes a lot of friction, and we want to get out of this pattern. So that's why we want to reimagine our single-page application as a platform. So platform is nothing but a group of capabilities that can be used as a base upon which other micro applications can be developed, and they can all be composed together to provide a single unified customer experience. So that there are three main fundamental pillars of a platform. They are consistency, reuse, and isolation. We'll see in detail each of these pillars. So the first is consistency. Since multiple teams develop different applications and they are all composed to provide a unified customer experience, it's very important to have consistent look and behavior across all the applications. So we can achieve these by using a common design system, common icon library, and common web component libraries. So common design system is much more than a style sheet. It is a single source of truth that can be used by designers and developers to develop their front-end application. So it should provide details on foundational concepts like accessibility, grids, colors, typography, and it should also give guidelines of content, language, error messages, and it should have detailed documentation of how you should apply styles for different HTML elements in different situations. By having a common design system, we can have a shared vocabulary across teams and across tech, product, and design. So for example, if you say informational alert, then everyone knows what it should look like and how it should behave based on the common design system. So similar to a common design system, we need to also have a common library for icons so that we can use the same icon across all applications, and also common web component library. We might have instances where we want to create a custom HTML elements. For example, if you want to create a custom input element for currency, then we can create a currency web component. And it can be consumed by all the applications. So when creating custom web components, it's best to use vanilla JS so that we don't have to worry about framework and version collision, and they can be easily consumed by the applications. So other candidates that are good for web components are like common headers and footers that are used across all the applications. More importantly, all the web components must be documented properly. And we also need to have a storybook for all the web components so that developers can go and reference that when trying to use that in the application. So the second pillar is reuse. So we want to reuse as much capabilities as possible and avoid redundant work. So all applications have analytics and A/B testing that they might want to perform. So those scripts can be moved to a common SDK and also common utility functions like validations and tracking user activities. All of those can also be moved to a common SDK so that individual applications can just consume the SDK and get those services. Similarly, entitlement and feature toggle services can also be part of the common SDK. And we can also create a reusable micro-frontends. So reusable micro-frontends are different from web components in that micro-frontend has a end-to-end feature. So it has a UI backend service, and then it interacts with data. So it provides end-to-end functionality for a particular feature. So we can also create micro-frontends as reusable components. When we do so, it's best to use vanilla JS so that if you have to embed this micro-frontend frontend into another application, we can avoid version and framework conflicts if it is built in vanilla JS. And then the last point is to create a shared infrastructure. So instead of each team having to host their application in their own container in ECS, we can have a shared infrastructure which can host all the static assets so that all of the DevOps work is abstracted from the teams. And we can also enhance it in such a way that it has a connectivity to SSO and API gateway so that it comes out of the box for the application teams. And the final pillar is isolation. It's very important to enable teams to develop and deploy their applications independently. So in order to do that, we make use of a micro-frontend architecture. So micro-frontends enable us to create teams based on business domains, and it allows us to scale teams efficiently, and also it provides isolated failures so that failure in one micro-frontend will not affect other parts of the application. So there are several patterns that we can use to create our micro-frontends. We are going to discuss about 3 of them: multiple SPA, SPA with embedded micro-frontends, and SPA with module federation. So for the purpose of this demo, I have created a music store application. So this is how the application looks like. It has a home module, albums module, and events module, and it's part of a monolithic application. And in the backend, there are microservices for login, album, event, and order. So we want to convert this traditional monolith into a multi-SPA architecture. So in that case, what will happen is each of the route in the application becomes its own micro app. And based on the route that is requested, ALB will redirect the traffic to the appropriate container. So the consistency between these micro apps will be maintained by using the common components, SDKs, and styles. So there are several advantages to this approach. So this makes the micro frontends to be truly isolated because each micro frontend is basically a micro application, and each team can own their technology decisions. They can choose their own version and framework. There doesn't need to be any coordination between different teams. And you can reuse the micro frontend as a whole without integration. For example, if the albums micro frontend needs to be used in some other application, you can just add that route to that other platform so that it becomes available in that platform. It is great for linear applications. What it means is that, for example, if you take a loan, applying for a loan. So first step was getting pre-qualified. Second step is looking at the offers, and third is choosing an offer and then submitting an application. So it has a series of steps in a sequential order. So it is great for those kind of applications in that each route could become its own micro frontend. So there are some considerations that we need to take when using this approach. The first is state management. Since each application is independent of the other and doesn't have a knowledge of the other application, it's very important to have a minimal data communication between the micro frontends, and we can make use of query parameters, session storage, and local storage to pass some minimum data between applications. And also the second one is to keep an eye on performance, because every time we are bootstrapping a new application, so we can make use of some techniques like preloading our static assets, and also using service workers to create cache for static assets. We can make use of those strategies to manage some of the performance issues, but we need to keep an eye on performance. And we also need to have thoughtful transitions. When we move from one micro app to another, we essentially unload the first app and then reload the second in the browser. So we might encounter the white screen. So in order to avoid seeing the white screen, we need to add some kind of animation or spinner that gracefully transitions the user from one micro app to another. So let's look at a demo of this. So I've already started our application. So here I have the home running in port 4000, and I have our albums micro front end running in 4001. So each micro front end is its own micro application, and it bootstraps its own app. And let's see how when we move from home to album route, how the transition happens. You can see that we saw a spinner, and it gracefully transfers us to the second micro app, which is hosted in 4001. And similarly, when we move to events, it loads our third app, which is hosted in 4002 gracefully. So we need to think about how we transition from one application to another, so that although we are loading new application, it feels like a single page experience for the user. And the next pattern that we are going to see is SPA with embedded micro-frontends. So in this case, there will be a shell application which will host other micro-frontends. So the shell application is responsible for routing the traffic to different micro-frontends based on the route. So the shell and all the micro-frontends will make use of the shared components, SDKs, and styles. So let's look at the two different integration patterns that we can use for SPA with embedded micro-frontends. The first is we can publish our micro-frontends as library packages, and these packages can be referenced in the shell package.json file, so that whenever the shell application is built, it will pull the code for the micro-frontends and bundle it together and have a single bundle which is deployed to the server. So there are advantages and considerations in this approach. The advantage is that since all the micro-frontends are added during the build time, we can do tree shaking and remove duplicate code. This makes the bundle size much smaller, and it improves the performance. But on the flip side, there are some considerations that they are not truly independent, because whenever you make any change in your micro frontend, you have to publish a new version of the package, and that the new version should be updated in your package.json file in the shell application. So whenever you deploy your micro frontend, you also need to deploy your shell application. So there's that dependency, and micro frontends must use the same Angular framework and version, or micro frontends can be created as vanilla JS. And there should be minimal communication between your micro frontend and the shell application. You should not have a lot of input and output events between the micro frontend and the shell application. The second integration pattern for SPA with embedded micro-frontends is runtime integration. So in this case, the shell application dynamically loads the requested micro-frontend assets in the browser at runtime by adding the script tag and element tag. So how this works is whenever micro-frontend is requested in the shell application will make a call to get the latest version of the micro frontend, and then load the latest asset files on the browser by creating the script tags. So all of our micro frontends will be running in their own containers in the ECS cluster, and whenever we deploy new changes, it also deploys a version.manifest.json file, which actually maps the static asset with the latest version that has been deployed. So shell application will get this manifest file, read the main.js version that's latestly available, and then add a script tag for that. So this way, the micro frontend is dynamically loaded at runtime. So there are some benefits and considerations to this approach. So the benefits are the micro frontend and the shell application are truly independent. You can deploy your micro frontend separately and the shell application separately. Whenever the browser is refreshed, shell application will pull the latest copy of the micro frontend. And we can have lazy loading of the micro frontends only when when the particular micro-frontend is requested, the script will be downloaded. And then it's well suited for micro-frontends with back and forth interaction, because it's very similar to having moving two different routes in your single page application. It will render the micro-frontends much faster. And there are some considerations for this approach as well. So the first is bundle size, because the micro-frontends are not known during build time. When it is loaded on the browser at runtime, we need to be cognizant of the bundle size, so that we can approach this in two ways. The first is create our micro-frontends as a vanilla JS, so that the bundle size will become much smaller without the framework. The second approach is to use the same versions and packages across micro-frontend and the shell application, and reference global object to download these common dependencies. So we can by using Webpack externals, we can achieve this. So in order to use Webpack externals, we make use of the ngx build plus a package that is created by Manford Steyer. We add that to our project and we generate ngx build plus externals. So what this will do is it will load Angular files as UMD bundles, and it will map the UMD bundles to window.ng global reference, so that when shell and micro-frontend requires these UMD bundles, they will get it from the window.ng object. So here the other considerations, framework compatibility, since micro-frontend and shell application need to reside together, it's best to use the same version and framework. Otherwise, we might encounter some unexpected gotchas. And also, when there is any breaking contract change in the micro-frontend, then at that time we might need to deploy our shell application. For example, if the shell application expects a particular input property, and the micro app MFC removes that input, then we need to make that change in the shell app. So a demo for this pattern. So in this case, like when I first load the application, you can see all of my RxJS and Angular core and other dependencies are downloaded as UMD bundles. And when I move from one micro-frontend to another, the first call that happens is searching the version manifest.json. So it has a mapping of main.js with the latest version of main.js, and then the shell application downloads that main.js version, and then also adds a script tag to the body. So this way, the micro-frontend is dynamically lazy loaded, and also we get the latest copy of the micro-frontend every time. And the last pattern that we are going to see is SPA with a module federation. So Webpack 5 module federation provides efficient way for sharing libraries between your shell application and micro-frontends. In Angular 11, Webpack 5 is available as an experimental feature. We are making use of the Angular Architect module federation plugin in order to create this demo. So when we add this module federation plugin, it creates two Webpack configs. So one is for the micro-frontend and one is for the shell application. In the micro-frontend Webpack config, you can see there's a new plugin for module federation, and it you specify the name of the micro-frontend and the entry file for your micro-frontend, and also the modules and components that you want your micro-frontend to expose. You can specify any module and component defined in your micro-frontend here. And shell application should be able to consume it easily. And then the shared object has all the libraries that are shared between shell and micro application and the micro-frontend. So here there are two properties, singleton and strict, and both are set to true here. But you can have a different combinations here, which I'm not going to go into detail. But setting these two to true means that we are going to use the same singleton version, a singleton copy of the singleton copy of that library, and we are going to use the same version. So it is recommended to have a same version and framework across all your micro-frontends and shell applications, so that we don't run into unexpected change detection issues and unexpected routing issues. So similarly, in shell app also you have this shared object with the libraries that you share, and also the remote object. So in this you can hard code the micro frontend and the JS file that you want to download. But instead of hard coding it here, we can also do a lazy loading by using a load module load remote module function that is exposed by the module federation plugin in order to do lazy loading of your micro frontend. So let's look at a quick demo of this. We're going to see the same music store application. So here, when I move from my home page to the albums, you can see that it downloads the remote entry.js file, and then adds a reference of that file to the DOM. So by this way, the micro frontend is lazy loaded, and we are able to easily manage the dependencies between shell application and the host application by using a Webpack 5 module federation. So this concludes the demo for all of our micro-frontend architecture patterns. So the key takeaways are there are no one-size-fits-all pattern. So based on the necessities of your team, you can choose either multiple SPA or single SPA with micro-frontends. So when you use multiple SPA approach, you can use different frameworks and versions. But with SPA with embedded micro-frontends, you cannot use multiple frameworks and versions to prevent unexpected gotchas. And it's not that you cannot, but it's not recommended to use multiple frameworks and versions. And then micro frontends are suitable for large UI applications in which multiple teams contribute. It's not suitable. It's not needed for smaller applications. And the third is if you want to build reusable micro frontends, it's best to build it in vanilla JS so that they can be consumed across multiple applications without considering the framework and version collision problems. And then we have to keep the interaction between micro-frontends and the micro-frontend shell application to a minimum. And we need to use custom cache busting solutions when we use dynamically loaded micro-frontends. Finally, micro-frontends are suited for scaling teams. For example, if you want to create a new pod to work on a specific feature, then instead of disturbing any of the other teams, you can set up a new team and have them work on a micro frontend and integrate it with the bigger application. So that's a very important benefit of having a micro frontend, that you can scale teams. So in conclusion, by using the common design system, web components, SDKs, shared infrastructure, and the micro frontend patterns, we are able to create a platform for our UI application development and enable teams on delivering core business values. So this concludes my session today. I'm very happy to answer any questions. Thank you for listening to my talk.